Hi, in this video we'll solve an IB style probability distribution question using a graphical display calculator, specifically the TI-84 plus CE. We'll find probabilities, the expected value, standard deviation, variance, and I will draw the histogram using this given probability distribution. I will also try to highlight common IB exam mistakes to avoid. So let's take up one example. The example is a diagnostic test correctly detects a disease 60% of the time. 5 patients are selected at random. Probability distribution is given. Discrete random variable values are 0, 1, 2, 3, 4, 5 and corresponding probabilities. Part A of the question is show that it's a valid probability distribution. So let's start with part A first. For a probability distribution to be valid, all the probabilities should be between 0 and 1. So we can see all the probabilities at x is equal to x are between 0 and 1. And then the sum of all the probabilities should be equal to 1. That's property number 2. So we can see that all the probabilities are between 0 and 1. So first condition is satisfied. Let's check the sum. So sum 0.010 plus 0.077 plus 0.230 plus 0.346 plus 0.259 plus 0.078, and that's equal to 1. So sum of all the probabilities is equal to 1. So second condition is also satisfied. That means it's a valid probability distribution. B part. B part is probabilities of x greater than or equal to 2. Means we'll add all the probabilities which are greater than or equal to 2. So sum of all these probabilities, we can quickly add them. 0.230 plus 0.346 plus 0.259 plus 0.078, and that's equal to 0.913. It's equal to 0.913. C part. Probability that majority are not correctly diagnosed. So that means majority of 5. You can see that majority of 5 equal to at least 3 failures. That means we want to find probability of random variable x less than or equal to 2. That means we will add all the probabilities. We'll add all the probabilities which are less than or equal to 2. These probabilities. So we'll add them all to get this answer. So let's add them all. 0.010 plus 0.077 plus 0.230, so that's equal to 317. 0.317. C part. Now so D part, we have to find expected value. Expected value, when we are using probability distribution, we use expected value, but for data values we use x bar and mu also. They have the same meaning, but x bar is used for data values, expected value used in case of probability distribution. So let's go to the screen, press mode, go to stat, edit, enter, clear anything if there is in L1 and L2. So in L1 clear, enter, in L2 clear, enter, and then enter the discrete random variable values in L1 0, 1, 2, 3, 4 and 5, and then L2 all the probabilities, corresponding probabilities very carefully in order to avoid any silly mistake. Any error in the entry will lead the wrong answer, hence deduction in the marks or no marks. Okay, so 0.010 first entry, 0.077 second entry, 0.230 third entry, 0.346, 0.259, 0.078, and so on. Hence we enter the corresponding probabilities. Now we go to stat again. Calc, we want to calculate one variable statistics. So calculate, make sure that frequency list we have L1, frequency list we have L2. If L2 is not there, by default many times the frequency list is empty. So we use second stat and enter L2 and then enter and enter, we get all the statistics. So here we have population standard deviation, sigma x, population standard deviation. Okay, first we answer D part, expected value, the average. So average is equal to, you can see x bar 3.001. How we will interpret? That means that is the average. That means on an average 3 out of 5 patients are correctly diagnosed. Now E part is we are not concerned with sample standard deviation. We are concerned with population standard deviation as IB requirement. So that is sigma x, that's equal to 1.094, 9 rounded to 3 significant figures, 1.09, 3 significant figures, and then we need variance. So we know that variance is nothing but the square of standard deviation. So we can use calculator also for that. So we go to vars, we press number 4 or 5 statistics, and we press number 4 standard deviation and square it. That's equal to 1.19899. So approximately 1.20 correct to 3 significant figures. So use the scatter plot. We want to draw the histogram. We press second, y equal to, turn on the plots. Okay, first we press second, y equal to, turn on the plots. That means number 5, plots on. Again second, y equal to, select plot 1 and enter what type of plot we want. We want histogram, so we enter histogram. Then we L1 x list, make sure x list is with L1, frequency with L2, and then we go to window, because it's very important to enter the window x minimum, because we know here the minimum value is 0, so we may enter 1 below than 0, so that's -1, and then maximum is 5. We may enter 7, 8 or 6, maybe 7. Okay, so we can enter 7, and then scale as 1. Then y minimum, as we have minimum is 0.01, so we can take -0 in order to make sure that we can see the correct histogram. So y maximum is 0.3, so we can enter maximum 0.4 or 0.5, so maybe let's say 0.5 and scale as 0.1, and then we graph. We'll get a nice histogram on our screen.